Hello everyone, I'm Luke from MLabs. Today I'm excited to walk you through milestone 3 of our Conway upgrade proposal. In this milestone we delivered 3 major sets of updates to the YTxP library. These included, of course, v3 Ledger API support and also some technical debt cleanup in the core library. We added support for the new Conway script purposes and selective compilation via our CLI tool, plus of course updated documentation and benchmarks. Looking at PR number 40 here, this PR merged 60 commits across 44 files, and you can see the many updates that we made for this milestone. Moving to the main ones, we updated the yielding script to include the Ledger API v3 version here, and then we also began marching directly on the new Redeemer structure. In Cabal.project, you can see the refactoring that we did, the technical debt that we addressed here. We removed liquid libs, mostly because it was deprecated, and also SC tools that we had used for indexing. Here in this commit, this handles the main testing utils and test updates that we handled. Essentially, this was reconfiguring tests to handle the new Redeemer structure. And then finally, in the main module entry point, we updated this to support Bluetooth Ledger API v3 instead of v2. If we move to the terminal here, you can see that I am in a Nix shell, and if we run the test, we can see soon that all of the tests still pass. In this next section, you'll see we now support the new script purposes added in Conway. And actually, we were able to do this in a highly ergonomic way. So still in PR40 here, you can see yielding script types used to be separate, but are now unified internally, which is due to the new Redeemer wrapper structure. Also looking here at scriptbuilders.hs, this means that the new script context can now be accessed from the context of a single reader rather than several individually typed readers, as was the case previously. This is also apparent in the test associated with Script Builder. Moving on to the YTxP test repo, we created a test suite relying on our Cardano Ledger backend emulator, which is CLB for short, to emulate the node in order to demonstrate that the yielding script is indeed triggering the new Conway transaction type. So interestingly, CLB is paired closely to the Atlas PAB, and this is actually a product of Project Catalyst Fund13 that we built out, and we're happy to use it here. Our test suite leverages several of these integrated testing utilities. So looking here, you can see the test suite now covers the 5 script purposes: minting, spending, rewarding, and most importantly for this milestone, certifying and voting. And looking at the test initializations, you'll notice that there's a sort of distinct pattern. So a TX transaction family is deployed here. Then finally, the next, the transaction components are activated and built out here. And then finally, the transaction is submitted, executing the yielding script action on the particular script type. And it's the same sort of pattern here. So that is deploying the token transaction family transaction, and this is building out the body, and then this is submitting and triggering the yielding script action. Here in the terminal, we can then run these tests. So I will show you that I am again here in the Nix shell, and then if we run the make test all, we get a very long trace, but importantly, noting that all 5 tests passed. This trace is quite involved, but fortunately, we can kind of grep around to see some things happening here. Here we can see a 0 Lovelace withdrawal from a staking validator. If we search for this, we can see some certificate issuance happening here throughout the throughout several test types. And then finally, we can also see some DREP voting procedures here. And then again, of course, all 5 tests are passing. There is one caveat here to notice. You'll notice that there is no proposing script purpose, so that has not been addressed in this test suite. This was intentionally omitted because as we progressed with this process, this project, it became clear that unlike the other script purposes, proposing introduces a potential security concern, and that is the on-chain proposal logic itself could be swapped out mid-vote. And of course, this would undermine the integrity of the vote. In this case, this is a feature of YTxP, and it's part of its flexibility, but it would work against us. So we decided to highlight that concern here rather than ship it unguarded. Finally, let's cover PR47, which adds selective compilation support across the CLI, library, docs, and tests. This chain touches 12 files, and we'll look at a few of them here. Firstly, and probably most importantly, is the readme.md. Where we documented that we introduced a new TXF-purpose flag. This means that you can now specify which script purposes are authenticated, and you can also specify the number of certifying validators, voting validators, and so on with the related options. Next, in the main.ahs, for the CLI tool, you can see that the compilation config constructor is used to set the type of selective compilation. And finally, before we move to a demo of the CLI tool, here in selective compilation benchmark.md, I wanted to highlight the benchmarking document here showing script sizes as you compile for different purpose combinations. As you'd expect, the greater number of purposes compiled, the larger the script size. But anyways, here in the terminal, one more time, you can see that we are still in a Nix shell. And if you run the command that is contained in the README, you will see that it generates a blueprint.json file here. So this blueprint.json file contains the requested scripts from the command that is, let me see here, 5 staking validator entries and 1 minting policy entry, as well as the core spending validator. But because we passed the TXF-purpose rewarding flag, every one of those on-chain scripts is compiled so that its logic will only succeed on a rewarding redeemer. And actually, if you were to interact with this compiling code, this compiled code, you can see that for yourself. Thank you.